We're going to take a look at right triangle trigonometry. This will be a review of most of what you've done maybe in geometry class in order to set us up for how we're going to do trigonometry in Algebra 2. So first of all, let's start with talking about what trigonometry is, and then our objective will be to use right triangle trigonometry to solve problems. So first of all, the study of trigonometry is the study of the relationship between angles and sides in a triangle. So now when we look at this, we're going to talk about the ratios that are set up by using the basic trig functions, which you have been most likely introduced to. That would be sine, cosine, and tangent. And then we're going to also introduce, or you may have been exposed to already, their reciprocals. The reciprocal of sine is cosecant, the reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. So let's look at this. And we use this phrase SOHCAHTOA and the initials there to help us understand the relationship to a triangle. So if this is our angle theta, using the Greek letter theta, then we look at this and we talk about always opposite the right angle is the hypotenuse, then the other side adjacent to it. So notice that theta here is attached to the hypotenuse. It's also attached to this leg. So the leg attached to the angle is called the adjacent side, and then the leg opposite the triangle from the angle theta is called the opposite side. So using opposite, adjacent, hypotenuse, we'll be able to set up the trig ratios. So first of all, sine is the opposite over the hypotenuse. So if you know the opposite side and you put it over the hypotenuse, that ratio is what sine of the angle equals. Cosecant then would be the reciprocal. So we put the hypotenuse over the opposite side. Cosine is the adjacent side, the one next to it, over the hypotenuse. Now you might notice again, that's the A and the H, adjacent hypotenuse, that goes with cosine. Secant would be the reciprocal, so it's the hypotenuse over the adjacent side. And lastly, tangent is going to be the relationship between the angle, the side opposite the angle and the adjacent. That ratio set up. So we'll put opposite over the adjacent. Cotangent would be the reciprocal of that, so we do the adjacent side over the opposite side. So SOHCAHTOA helps us see sine, cosine, tangent, and then we use these as the reciprocals of those. Now let's use that in some problems. We want to set up problems sometimes that have real world situations. So we sometimes will use the angle of elevation and the angle of depression. Now the angle, both of these relate to the horizontal. So when you're measuring the angle of elevation, you measure from the horizontal okay, and then, so if this is my horizontal line, then you want to, since it's elevation, you want to go up with it. You want to have an upwards looking angle. So this would be my angle theta. So measure from the horizontal and then looking up. Now, as you can imagine, then angle of depression would be looking from that horizontal and then looking down. So we want to measure from the horizontal again. be looking down to get this angle. So for this one, our angle would be, look at our horizontal, and then we would have our angle that looks down from there. That would be our theta in this case. It's important, especially for the angle of depression, because a common error is to not measure it from the horizontal, but some people by mistake measure it from the vertical. They'll measure this angle, which is more of a looking up angle from the vertical, instead of from the horizontal looking down. It's very important to make sure we put the angle in the right place. So from the horizontal, always either looking up or from the horizontal looking down. Let's go ahead and do some problems here. Let's go ahead and find x in this case here for this problem. So for this one, we want to look at what is given to us. It appears we want to find the hypotenuse. And then if we look at the angle given to us here, this angle given to us, this side is adjacent to it. It is connected. The hypotenuse is also, but we're looking for the adjacent leg. So this would be the adjacent and the hypotenuse. Let's go back and look which of the trig functions involves the adjacent and the hypotenuse, and that would be either cosine or secant. We'll use the cosine because on your calculator, the three trig functions listed on your calculator are sine, cosine, and tangent. And so I'm going to go ahead and use the cosine to help me with this problem. So I'll use cosine of the angle. Okay, so I'll just write which one I'm using. Cosine of theta is equal to the adjacent side over the hypotenuse. So I've got the angle given to me, so I'm going to go cosine of 39 degrees is equal to the adjacent side, which is 88 over x. There's my equation set up. Now I'm going to solve for x, so I'm going to multiply by x on both sides to get it out of the denominator. That equals 88. And now I'm going to get rid of the cosine of 39 degrees to get x by itself. So x equals 88 divided by cosine of 39 degrees. Now we want to turn to our calculator to do this calculation. Now it's important that you recognize two things. First of all, in the problems we're working with, are we looking at the angles in degrees, or we're going to introduce soon, or you may have already been introduced to, radians. That's another way we will measure angles in Algebra 2, but for now we're going to have our angles in degrees. So we want to make sure when we look at our calculator, if I go on to turn it on and then go to the mode, make sure that your angle measures are in degrees. Second thing I want to know about for this problem is, what am I rounding to? Now this oftentimes will be given to you in directions or by your instructor. For this problem, or you might use significant digits like you do in science. For me, on this one, I'm going to go ahead and use, since this is rounded to the nearest unit, I'm going to round this to the nearest unit, okay? So on this, I'll take a look now, and I'll take 88 and divide by the cosine of 39. So a cosine of 39, I'm going to close the parentheses on the 39. I don't have to put in a degree symbol because the mode is already set to degrees for this. Hit enter, and I get 113.2348. So I'm going to round that to about 113. Okay? If you're doing significant digits, it was likely round that to 110, but we'll use the nearest unit. So 113 is my answer for that problem. Notice we use the relationship between the angle and the sides, then the ratio of sides, in order to solve for the missing side. All right, now let's go ahead and look at number 2 here. If I look at the information given to me, I'm given an angle. I'm looking at the opposite side and the adjacent side. Well, if you look back at your notes above, the one that has opposite and adjacent is tangent. That's the TOA part, T-O-A, for opposite over adjacent. So I'm going to use that formula. Tangent of theta is equal to the opposite over the adjacent. So now I'll use tangent of 28 degrees is equal to the opposite, which is x, over the adjacent, which is 56. I'm going to multiply by 56 on both sides to get the x by itself. So 56 times tangent of 28 degrees. It's going to be my answer for x. Let's go ahead and do that on our calculator. So we're going to have 56 times tangent of 28 degrees, and close the parentheses on that. And I get about 29.7757, etc., which if I round to the nearest unit, which I'm going to do in this problem, that's going to be 30. So 330. So my answer for this is x is approximately equal to 30. Our answer. Now let's take a look at this last one here. It says it's a word problem. It uses the angle of elevation here. It says Jack throws a frisbee at an angle of elevation of 15 degrees. Well, I'm going to first of all draw the angle of elevation. So from the horizontal, 15 degrees looking up. So it's going to go up like this. So 15 degrees is what my angle is there. Now, it says if it ends up hitting an object 20 feet in the air. So I'm going to put this here and say, okay, this is 20 feet up, all right? It says how far on the slant did that frisbee travel? So I want to know what this is here. That's my unknown, is how far from here to here did it travel? Well, if I look at the information given to me, I'm given the angle, the opposite side, because it's not the adjacent, this would be the adjacent. This is the hypotenuse. So the opposite side and the adjacent, the trig function that is opposite and adjacent is, opposite and hypotenuse. If I look back at opposite and hypotenuse for my choices here, opposite and hypotenuse is the sine function. So I'll use my sine function for this one. So if I set up my trig function, I'm going to have sine of theta is equal to opposite side over hypotenuse. Now when I put those values in that I know, I'm going to have sine of 15 degrees is equal to the opposite side, which is 20, over the unknown, which is x. Now to get that x out of the denominator, I'll multiply both sides by x. So I have x times sine of 15 degrees is equal to 20. Now I'm going to divide both sides by sine of 15 degrees to get x. So 20 divided by sine of 15 degrees. We can do that on our calculator. So we'll have 20 divided by sine, get the sine function, of 15 degrees. And now I hit enter, and it looks like I get about 77.274, or if I round to the nearest foot in this case, because that would be the nearest unit, I'd get about 77 feet. So this travels about 77 feet on the slant. So in summary, this is a review of right triangle trig. We're going to use the basic three trig functions, which are found on your calculator: sine, cosine, and tangent. And we're also going to use their reciprocals. Those reciprocals are cosecant, secant, and cotangent. We'll use those to solve problems, to set up using the information given to us, the relationship between angles and the ratio of sides.